Okay, this talk is Factoids of Relativity. A factoid, I'm taking this defined as this from the Oxford Dictionary. There are other possible uses of the word factoid, and I think there's a problem between America and Britain where the word gets used differently, but I'm going by this definition here. It's a factoid is an unreliable piece of information, and as reported so often, it often becomes accepted as a fact, but it's not really a fact. Right, so let's look at some examples of factoids. Christopher Columbus discovered America, ? A lot of people say Columbus discovered America, and it seems to be a part of common knowledge. So if you look into it, you find that Columbus did not get to the United States. He went to the islands around America, he went to Central and South America, but he didn't get to the North America. But some people will argue that effectively counts as discovering America. So this statement that Christopher Columbus discovered America, it needs provisos added to it. And here's another example we're looking at. The first president of America, George Washington, ? And I think people normally say that the first president of America was George Washington, but when we look into it, George Washington was not the first president of America. This is because the first president of America was Randolph. You can look this up, and he was the first president of the Continental Congress, and some people will argue that that is not what we would nowadays count as being a president of America. And George Washington was president of the convention, where he's the first to sign a constitution, and this is when most people think the president of America started from. So when you say the first president of America was George Washington, really you should include provisos that you don't count the people before him. Thus, what most people know as common knowledge isn't really facts and are instead factoids. What they believe is not facts but factoids, i.e. statements that really need provisos added to them. And the bad part is that factoids are usually what is taught. When I found out that most people's common knowledge is really factoids, that disappointed me. Belief in factoids is the norm in our society. People don't go by facts, they go by factoids, and people are often deceived that they're going by facts and not factoids. They don't really notice the difference. So we want to apply this to relativity. What most people say about relativity is factoids. They're statements made in the context of relativity that really need provisos added to them. In my last talk, How Relativists Lie, I pointed out that relativists commit the sin of omission, where they make a claim or claims and they omit provisos of that claim. So, in other words, relativists usually state factoids and not facts, omitting the provisos makes what they're saying factoids instead of facts. And the bad part of it is that factoids are usually what is taught. Common knowledge is often totally false in any subject. Belief in factoids are the norm in our society. So the example I gave in my last talk, relativists will usually claim that experiments support special relativity, but omit saying experiments can be interpreted by other theories. This leads to the following communication problem. People end up talking at cross purposes. If you try talking to the average person who believes he knows about relativity, most of the time they believe factoids and not the actual facts. So trying to communicate with them usually gets nowhere. What they're taught about relativity is usually wrong. Another example of factoid in relativity, but more complicated because it merges in with a problem that Einstein did not write very clearly as to what he meant, and can be interpreted in different ways. So we look at this. It's the ether issue. It's the idea of a medium for the waves of light to travel through. If we look at Einstein's 1905 paper on special relativity, he says the ether is superfluous. So somehow Einstein saying the ether is superfluous gets interpreted by many relativists, that's the followers of Einstein's relativity, as meaning Einstein's saying the ether doesn't exist. As an example of people saying that, this New Scientist article, 30th October, claims Einstein killed the ether. Now the article wants to bring the ether idea back, but let's not sidetrack onto that. It is usually common knowledge that people are saying that Einstein discarded the ether, got rid of the ether, or killed it, as the New Scientist article was saying. So, did Einstein kill the ether? In 1920, Einstein seems to have come back to the idea of believing in ether and says, recapitulating, we may say that according to the general theory of relativity, space endowed with physical qualities, in this sense, therefore, there exists an ether. So it seems that Einstein was not rejecting ether, and so in 1920 could not have been interpreting the Michelson-Morley experiment as disproving ether. So the claims of later relativists about the Michelson-Morley experiment disproves the ether are false. Of course, it can lead to a lot of arguing as to what Einstein really meant, because he didn't write very clearly. So we could look at things as Einstein in 1905 says ether superfluous, and then take that to mean ether does not exist. Then in 1920 we could take that to mean he doesn't really mean bring back the ether. Then we can conclude that according to Einstein, in Einstein's relativity, there is no ether. But I think that is a false interpretation, and it should really be Einstein 1905 when he says ether is superfluous. He doesn't mean discard the ether, and so the ether still exists in the context of what he's writing in 1905. While in 1920 he is affirming the existence of the ether. Then we conclude that according to Einstein and Einstein's relativity, the ether exists. So what we can conclude about the ether existing or not existing depends on interpreting what Einstein says. So the claim by mainstream that according to Einstein in Einstein's relativity there is no ether should be added the proviso that depends on how one wants to interpret the very things Einstein says. So factoid is no ether, and to make it a fact we need to add it's a subjective to vagaries of interpretation of Einstein. Many problems like this exist in Einstein's relativity. Things are vague. Now this physicist, he's an Italian theoretical physicist. He says, on the issue of role of mathematics in physics, Einstein repeatedly shifted his point of view, advocating in the course of his life various ideas that were in direct contradiction of each other. So he's admitting that Einstein is contradicting himself. If we continue on with what he says, he thinks it is a good thing that Einstein changes his mind a lot. And this is what he says, Carlo says. Intelligence is not about stubborn adherence to your opinions. It requires readiness to change and even discard those opinions. In order to understand the world, you need to have the courage to experiment with ideas, not to fear failure, to constantly revise your opinions to make them work better. The Einstein who makes mistakes were errors, more errors than anyone else, is precisely the same Einstein who succeeds in understanding more about nature than anyone else. And these are complementary and necessary aspects of the same profound intelligence. The audacity of thought, the courage to take risks, the lack of faith in received ideas, including critically one's own. So he thinks Einstein changing his mind is a good thing. I think it's a bad thing that Einstein changes his mind a lot, because it makes it difficult to make sense of Einstein's relativity with all the factoids being presented. Einstein's relativity is a mess, and Carlo thinks it's a good thing, but it's really a feeble attempt by him to keep the mess. So what is special relativity? Now, special relativity seems to be 1. Principles, assumptions, postulates. I'm not going to go into detail about what what these words mean, but they seem to be basically what you're talking about is assumptions. And from those assumptions, that leads to some mathematics. And from that mathematics, you want to test that mathematics by experiments. So those are the 3 steps. So let's look at these steps. If we look, for example, at a website called Explorable Physics, it tells you special relativity is based on 2 postulates, which we take to mean assumptions. The first, the laws of physics are the same in all reference frames. The second is light moves at the same speed for all observers. Many relativity texts say the same sort of thing as explorable physics, but I found this person, Rosser, a senior lecturer in physics back in 1967, and he admits there are more than 2 assumptions, and he says, it must be pointed out there are additional assumptions implicit in the theory of special relativity. For example, it is assumed that inertial frames exist. And that is in his book Introductory Relativity. Not all relativity texts are so open with admitting that there are a lot of assumptions required to create special relativity. Anyway, saying a special relativity is based on 2 assumptions or postulates is a factoid. Not all relativity texts say that. What should be said is something like special relativity is based on 2 explicit postulates or assumptions, but there are hidden or implicit assumptions. So you've got more than 2 assumptions really. Just saying that special relativity is 2 assumptions is a factoid. And going back to the steps, it's not clear at step 1 what are the assumptions or postulates that we're going to start from. And then moving on from step 2 to step 2, we're not really sure what we're supposed to be deriving in the mathematics if we don't know how many assumptions we'd start using. And if that vagueness of assumptions then spills over to problems for testing in step 3, i.e. the theory is not properly defined if there is flexibility in what explicit and implicit assumptions are being used, because that then leads to different mathematics that can be derived from those different assumptions. You have steps 1, 2 and 3, and we haven't got it clearly defined at step 1 what are the assumptions. Instead of being clearly defined what the assumptions are, we are told a factoid. So, hitting a problem with steps 1 to 3 as to what special relativity is, we then need to check the references from what Einstein's working from to get his special theory of relativity. And Einstein provides us with no references as to what he's working from. So we hit a problem. We can't properly verify what the theory is about with steps 1 to 3, and we can't check how Einstein got to his theory. And it's for this reason I say special relativity is not a properly defined theory. have been looking to try to solve this problem, and my research suggests that Einstein wasn't the main contributor to special relativity and didn't properly understand the theory, and I refer you to my talk on that. Anyway, putting aside that other talk, what we're faced with here in this talk is special relativity is not a properly defined theory. It is based on factoids and not facts. Sufficient explanation has not been given to expand those factoids to make them become clearly defined facts. Thus, when we get to the issue of testing special relativity, we can't do it because special relativity is ambiguous. It can be modified in many different ways and not as a theory that allows itself to make some definitive explanation that can be tested. So, according to the philosopher Popper, we should test theories. He's been very influential in the philosophical basis of science as to what are scientific theories. But if you don't have a properly defined theory, then you can't really test it. Special relativity is not properly defined. Being not properly defined, you can't test it. And if you can't test it, it's not really a scientific theory. Well, at least according to Popper and many other people. You need to be able to test a theory, and the vagueness of special relativity means you can't test it. Special relativity can be modified to fit many different explanations for experiment. Anyway, at least what is taught about special relativity is not a scientific theory. It is a collection of factoids that fail to give sufficient information to make those factoids become facts. What people know as special relativity is a messed up collection of beliefs, factoids. And if we tie this back to the beginning of the talk, I pointed out my disappointment when I found out that people in general do operate from factoids and not facts about most anything. Special relativity is then just another subject area of people working from factoids instead of facts. Now, as a side note on this issue of factoids, if you're working for factoids, it means you're working from incomplete information. The news media deals with factoids quite a lot of the time. The reason it is the audience they are communicating with do not have time to deal with the full details of the facts. So the communication is shortened to simplify the message or messages and presents things as factoids. Now, factoids is the reason why people want to kill each other. People are working from factoids and not facts, although often they deceive themselves that they are working from facts. And then various groups working from different sets of factoids meet, and then they want to kill each other. So thank you, that's the end. Cheers.